Hello, my name is Clarence Mayott. I'm an application engineer at Linear Technology. When we send you a high-speed ADC demo board, we also send you the tools to evaluate that demo board. That's PScope, Linear Technology's data collection software. It's as simple as it is powerful. In order to get the demo board working, you will need to apply power, a clock signal, and an input signal. To get the datasheet performance, filters will also be required. You will also need a data collection system. Linear Technology provides several data collection boards and one piece of software to handle them all. When you open PScope, you will see 3 empty windows. Before we can look at the features of PScope, we'll need to collect some data. We are collecting data from the DC854D-A demo board, which includes the LTC2208 ADC. We are sampling at 100 megasamples per second, and we have an input frequency of 70 megahertz. PScope needs to be configured with the desired sample rate, transform size, and desired window. We first enter the frequency which we are sampling at, 100 megasamples per second. Then we select the transform size and window we wish to use. We will be using an 8K transform, and since we will not be using coherent sampling, we will need to use a Blackman-Harris window. In the status menu, you can see that PScope automatically finds and configures the demo board accordingly. With the demo board properly connected, we can hit collect and data will automatically be displayed in these 3 windows. The top window shows the input data sampled point for point from the ADC. The second window reconstructs one period of the waveform from the input data. This is called the P wave or primitive wave. It only contains valid data when sampling coherently. The third window shows the FFT of the input data. The fundamental and harmonics are labeled in red, and the yellow line shows the average noise floor. These windows are standard windows. PScope is easily customized to display any data that you want. Customizing the display is done by moving the mouse over the sides of the graph. And depending on the size, you can either pan or zoom the data in the window. If a more accurate window is needed, simply right-click and select Set Graph Limits to customize the display area. By right-clicking and hitting Restore, the default zoom will be displayed. It is also possible to change the displayed windows and display other useful data. If we click here on PScope, we can remove the P wave and replace it with an inverse Fourier transform. The inverse Fourier transform is useful when using vector averaging feature, which is covered in a later video. Now that we have the display showing what we want, let's discuss the results PScope is showing. PScope calculates the signal-to-noise ratio, spurious-free dynamic range, and several other parameters automatically. These values are displayed here on the side. If you look here at F1 amplitude, you can adjust your signal generator to produce -1 dBFS. This means that the input signal is 1 dB below the full-scale range of the ADC. The SNR is 75.16, shown here relative to full scale. So another 1 dB can be added to give a total SNR of 76.16. The SFDR is calculated and shown here. It is calculated by adding the sum of the square powers of the harmonics and taking the square root. Synad, THD, and ENOB are also calculated and displayed here. The DC level shows where the DC offset is in terms of LSBs, and the noise floor is shown is the average noise floor. On the right-hand column, we can see the power in each of the harmonics relative to the amplitude of the fundamental. The noise floor is calculated by averaging all the FFT points in green. This represents the SNR of the ADC plus the processing gain of the transform, which is 10 times log of the transform size divided by 2. PScope allows you to change what is considered part of the noise floor by applying a noise mask. This is done by selecting this button on the toolbar. Then selecting Auto Mask. This automatically excludes the fundamental and harmonics from the noise floor calculation. Then mask by using the mouse to click and drag over any area you want to exclude from the noise measurement. The area around the fundamental is noise from the generator that is getting through the passband of the filter, so it does not need to be part of the noise calculation of the ADC, and therefore can be discounted and masked out. This will exclude it from the SNR calculations, so the SNR will increase and the noise floor will decrease, as we see when we hit Done. There are other advanced features of PScope, like a two-tone test mode and an ACPR measurement mode. These can help in measuring intermodulation distortion and adjacent channel power ratio. These advanced topics will be covered in future PScope training videos. PScope will allow you to quickly and easily evaluate Linear Technology's high-speed analog-to-digital converters. For such a simple program, it is very powerful and makes complicated measurements in seconds. This will also allow you to spend more time on your design and less time with demo boards. For more information about PScope ADC software, please visit www.linear.com.